All right, you guys, it is that time again. I am Mr. Moore, and I'm here again with you talking about calculating experimental probability. As we see, this is 7.6i. 7.6i is multifaceted in that it has a lot of information there, and there are nuances, meaning little parts that are very important that I'm going to go over individually with you guys. So this particular part is calculating experimental probability. Now, as the slide here says, you can use experimental probability to estimate the probability of an event. The experimental probability of an event is going to be found by comparing the number of times that the event occurs, also known as your favorable outcome, to the total number of trials, okay? So when there is only one outcome for an event, we call that a simple event. So rolling a dice or flipping a coin. These are simple events where there can only be one possibility in terms of what comes up. So it can either be heads or tails. If it's a number cube, 1, 2, 3, 4, 5, or 6. Okay? So as we notice here, the formula there is experimental probability would be the number of times that an event occurs over the total number of trials. So if we look at this particular example, it says that Martin has a bag of marbles. He removed one marble, recorded the color, and then placed it back in the bag. Okay, and that's going to be super important in this particular example. He places it back in the bag. He repeated this process several times and recorded his results in the table. Find the probability of drawing each color. Write your answer in its simplest form. So basically what he did is you see there in that green A, the number of trials was 50. If we notice here, he pulled red out of the bag 12 of those 50 times. He pulled blue from that bag 10 of 50 times. Green, 15 of 50 times. Yellow, 13 of the times. Now, again, over the course of those 50 trials, the number or the frequency at which those colors were chosen was recorded. Now, that's going to be very important in our calculation. So what I'm going to do now is I'm going to go over to our work. All right, so what I'm going to do at this moment is I'm going to show you how I'm going to set this up. So we notice here I've already created a colored chart, fancy, right? Okay, showing the frequency at which those items occurred. So we have our colors here, and we have our frequency or frequencies here. Okay, so what I will do is I will look individually at each one of those. Now, if you remember, we know that there are 50 trials, and I'm going to set out my experimental probability, okay, and I'm just going to call that EP, as the number of times that something occurred. So for the color red, for instance, okay, for the red, we have the number of times that something occurred, and I'll make that look a little bit better, EP. The number of times that something occurred, that's 12 over 50. And I'm going to simplify that out, but I want to set up everything first. We have the experimental probability for blue as being 10 over 50. We have the experimental probability of green as being 15 over 50, and we have our yellow as being 13 over 50. Okay, so what I'm going to try to do is I'm going to try to simplify all of these out as well. Okay, so what common factors do we have between 12 and 50? The largest one that I can see, okay, is probably going to be 2. So I'm going to divide each one of these by 2, giving me my simplest form. Is there any other common factor between this? So this is going to be 6 out of 25, okay? There's a 6 out of 25 probability based on the experiment that was conducted that we would actually choose a red marble. Okay, here, greatest common factor. One trick of the trade, if there is an ending 0, I can go ahead and simplify this way by canceling those out. this becomes 1/5. Okay, or I had a 1 out of 5 chance of choosing a blue marble. Here, greatest common factor, I think the one that I am seeing is 5. Okay, so I'm going to say that when I divide both of these by 5, this becomes 3 out of 10. So there's a 3 out of 10 chance that I would choose a green. And then over to this one, I don't see any common factors between 13 and 50. So at this point, this is in its simplest form, okay, for that yellow one. Now, I can equate these just as a little refresher to certain percentages and a decimal form, okay? This is just an addition that the kids will need. Okay, so in terms of a percentage, it's going to be 24%. Once I divide 6 divided by 25, it's going to equate to 0.24 in decimal form. For this, I have 0.2 as my decimal, or 20%. This one, I have 0.3, or 30%. Okay, and this is all by dividing this. If you are unclear as to how to do this, parents or somebody watching that isn't familiar with this process, I have a video on converting from fractions, decimals, and percents that I want you to take a look at. And then in this particular case, this is going to be 26% or 0.26. Okay, and that's pretty much it, you guys. Okay, calculating experimental probabilities. As always, if this video is helpful, give it a thumbs up. If you need to rewind the video to catch something that I said, please do that. Come to class with a question, or you may come to one of my tutorials twice a week. And unless there are any further questions, and I don't hear any, okay, I'm going to bid you goodbye at this point. And as always, I'll see you tomorrow.